All right, well, I ran out of time on that last lesson to do this example, so here I'm just going to do one example. But we got to do a little bit of prep work before we do this thing that we're going to do on example 5. Let me write down this phrase. It's called rationalize the denominator. And I'll tell you what that means here in a second, as soon as I finish writing this. Denominator. There we go. All right, so we're going to rationalize the denominator. What in the world does that mean? Well, mathematicians don't like to have a square root or any kind of root in the denominator, in the bottom of a fraction. That's why it's rationalized, because the word ratio is in there. That means it's a fraction. And what we're going to do, basically what it's saying, what math teachers have said for years and years, is that they don't want square roots in the denominator. All right, so that's what we're going to do. We're not going to ever write an answer like this with a square in the denominator. You will always have to rationalize the denominator for your final answer. Okay, so how in the world do we do that? Well, it's a good question. So what I'm going to do is we're going to hold off on this for just a second, and let's go over here off to the side. Let's do that in a different color just to make it stand out a little bit. And I'm just going to show you a couple little tricks. So for instance, if I had a square root, let's just use a different number since we have a square root of 2 here. I'll use a square root of 3 here. How in the world what could I do to this in order to get rid of the square root? And that's what we're doing right here. We're trying to get rid of that square root. So what could I do to this to get rid of the square root? Well, I'll just show you. What we could do is we could multiply it by the same exact number. Okay, when you multiply something by itself, you're squaring it, so I could show that too. But right now, we're just going to multiply by itself, just like this. So what is this? The square root of 3 times 3 is the same thing as the square root. You could put both of those inside of the square root. We went over that in the last, well, it's this section, but we went over it in the last video. And let's see what we get here. We get the square root of 9. What's the square root of 9? It's a 3. So guess what we did? By multiplying this square root by itself, we actually got rid of the square root. You could have also looked at it like this if you wanted to. If we square it, that square gets rid of the square root and we're left with a 3. But this is really what we're going to be doing right in here. So let's forget that part right there. I'm just going to get rid of that. All right. So that's one way we can get rid of a square root. Well, what if our square root was written just a little bit differently? Let's change colors on this one. So what if we had a square root like this? Let's use that square root of 3 again. And I'm just making this up. Square root of 3 plus 1. You could have a denominator with something like this, the square root of 3 plus 1. So how do we get rid of that square root? Well, I can't just take this and multiply it by the square root of 3, because if I did that, don't write this down, but if I did multiply it by a square root of 3, square root of 3 times square root of 3 is square root of 9, which is 3, but I'd also have to multiply it by this 1. So I'm still left with a square root. So I don't want to do that. So what I'm going to do is a thing called multiplying by the conjugate. What in the world is that? Well, the conjugate is basically just the same exact thing, except the sign in the middle is different. So if this was plus, this sign is going to be minus. So that's multiplying by the conjugate. So why in the world are we going to do that? Well, hopefully this will get rid of the square root. Let's see if it does. This is just a FOIL method problem. So square root of 3 times square root of 3. Well, we've already done that, so I can kind of do that in my head now. You should get used to that. Anytime you have a square root times itself, that gets rid of the square root, and you're left with whatever's inside of here. So square root of 3 times square root of 3 is just a 3. What about the outside and inside? Remember, doing FOIL method. So the outside is minus square root of 3, because it's square root of 3 times negative 1. Then the inside is positive 1 times square root of 3, which is a positive square root of 3. And then the last terms, positive 1, negative 1, you multiply those together, you get minus 1. Look what happens here, though. You actually get rid of these square roots, because negative square root of 3 plus square root of 3, that cancels out, or it adds up to 0. And then 3 minus 1 is just 2, and that's your answer. So look what we did. We started off with this, and the whole idea was to try to get rid of that square root. So how can you get rid of the square root? You multiply by its conjugate. I'll write that word down, conjugate. All right, so what is the conjugate? It's basically you're taking these two terms and you're just changing the sign in the middle. That's the conjugate. Anytime you multiply by the conjugate, it's a FOIL method where the outside and inside actually add up to 0. It's going to happen every single time. So really, all you have to end up doing is just multiplying the first terms together, multiplying the last terms together, adding or subtracting, whatever it tells you to do. It's going to be subtraction because one's plus, one's minus. But you subtract them. 3 minus 1 is 2. That's how you can get rid of that square root. Well, what in the world do we do with that 2? Well, I'm going to show you here in a second. So let's come over to this. And again, change colors. And remember, we don't want a square root in the denominator. This was just all off to the side, okay, because we're going to use this stuff in order to get rid of this square root. So if it's just a single square root, remember how we can get rid of that square root? Just multiply it by itself. So if I multiply the square root of 2 by itself, I'm going to multiply it by the square root of 2. Now, remember in fractions, I can't just multiply the bottom by a square root of 2 and then just work out and get an answer. Okay, I have to multiply the top by the square root of 2 as well. All right, because what is it in red? That's why I put it in a different color, because the square root of 2 over the square root of 2 is just a 1. Anything divided by itself is equal to 1. So really, what am I doing to this fraction? All I'm doing to this fraction is multiplying it by a 1. That doesn't really change the value. I shouldn't say it doesn't really change it. It doesn't at all change the value of this fraction. So I am allowed to do that. So what I'm going to do is let's figure out what the numerator is. So it's 1 times the square root of 2, which is the square root of 2. And I'm allowed to have a square root of 2 in the numerator. That's perfectly fine. It's just the denominator. We don't want, I don't know why, I think I read it one time. They gave some reasoning on why they didn't want the square root. I forget it off the top of my head. You could probably look it up. You got Google. But anyway, they don't want a square root in the denominator. So square root of 2 times square root of 2, remember how to do that? That's just a plain old 2. And that is the same thing as what we started with, that 1 over the square root of 2. 1 over square root of 2 is the same thing as the square root of 2 over 2. Why is this better? This is better because we don't have a square root in the denominator. All right? So hopefully that makes a little bit of sense. Let's do some real examples here. Let's go, we're going to do example 5. That's all this lesson is just example 5. So example 5. And it's got a few parts. It's got, what, 3 parts to it. So the first part looks just like what we just did. So I can do it really quick here. So 1 over the square root of 3. So what do we do with 1 over the square root of 3? We don't like this. The questions, I think it says to simplify. I just have my notes down and I didn't write what the question says in the notes. I think it might say simplify or something like that. Or rationalize the denominator, it might say. So how do we get rid of a square root of 3? Well, we multiply it by a square root of 3, but we got to do it to the top as well, because square root of 3 over 3, or square root of 3 over square root of 3 is equal to 1, and then it doesn't really change the value of it at all. So let's see what we get. Multiply the top. 1 times square root of 3 is square root of 3 over the bottom. Square root of 3 times square root of 3, you shouldn't even have to think. 3 times 3 is 9, square root of 9 is 3. You should automatically know whenever I take a square root, multiply it by itself, it's like squaring it where it gets rid of the square root, so I'm just left with that number. I'm just left with a 3, not a 9, but it's the square root of 9, which is 3, and that's my answer. Now it's simplified. Okay? Let's do another one that's very similar to it. Just looks a little bit different. So it's 5 over 4 times the square root of 2. It's really the same kind of idea here. So what don't we like about it? Why is this not simplified? I mean, nothing cancels out here. So what's not simplified about it? The denominator has a square root in it. We don't like that. So we have to get rid of that square root in the denominator. So what I'm going to do, it's what we've done twice already. I'm going to multiply the bottom by square root of 2 and multiply the top by square root of 2. That way, this will get rid of that square root. So now let's just do some multiplication and see what we have left. It's really the same kind of problem as this, just a little bit more complicated because you got some other numbers in here, but really it's no more difficult than this one. So the top, 5 times the square root of 2. This is not the square root of 10. This is a whole number 5. So I can't put them both under a square root. The only way I can write it is 5 times the square root of 2. That's how you would multiply those together. You just put them next to each other. For instance, like 5 times x. I can't simplify that. It's just 5 times x. I can't make it any easier than that. This right here is the same exact thing. Well, it's not the same exact thing, but it's kind of like it. 5 square root of 2. All right, let's do this. I've got a 4 here. Now let's multiply these two things together. Remember, square root of 2 times square root of 2 is just a 2. Now, you got to understand that it's also being multiplied. You probably could have done that in your head, and if you can, it's perfectly fine. Go ahead and do that in your head. But I'm going to write out the steps since I'm teaching it for the first time. And then 4 times 2 is 8. Nothing cancels. The 2 does not cancel with the 4 because the 2 is under a square root. Okay, it's not a 2. It's the square root of 2, which is some fraction, 1.14 or something like 1.4, 1.14, I forget exactly, but it's something like that. That is your answer. That's how you're going to leave it, just like that. All right, let's do this one. Now this one, it's a little bit harder than what we did in the first two examples. But it's that conjugate thing. It's multiplying by the conjugate. Now these look crazy because of all the square root things, and square roots scare people off. They really do. But if you learn the rules for square roots, it's really not so bad. So let's see what we can do to get rid of these square roots. Now there's 2 square roots in the denominator. We definitely don't want that. We don't even want 1 square root in the denominator. So what I'm going to do is I'm going to multiply this by its conjugate. Remember, when there's 2 things right here, we multiply by the conjugate. What's the conjugate? It's the same exact thing, except for the sign in the middle is different. So I'm going to write square root of 3. Instead of minus, I'm going to put a plus. And then this is also 3 times the square root of 2. Now, if we multiply the bottom by this, we have to multiply the top by the same exact thing. So square root of 3 plus 3 square root of 2. So I'm multiplying the top by this thing. I'm multiplying the bottom by this thing. So let's go ahead and do the multiplication and see what we get. Let's do the bottom first. It looks like the bottom might be more complicated, but it's actually pretty easy because remember, multiplying by the conjugate, the outside and the inside always add up to 0. So I'm not going to get a middle term. So really all I have to do is multiply the first and the last. So let's multiply these two together right here. Square root of 3 times square root of 3. Again, very easy. It's just a plain old 3. The outside and inside add up to 0. So all we have to end up doing is multiplying the last together. So let's do that. This is a little bit more complicated, but let's watch. It's 3 square root of 2 times 3 square root of 2. Let's do the 3's first. And by the way, it's going to be minus because it's a negative and times a positive. It's always going to be minus when you multiply by a conjugate. 3 times 3 is 9. Okay, and then square root of 2 times square root of 2 is just 2, just like that. So we'll multiply those together. We'll do that in the next step. That's pretty easy. Now, let's do the top. Let's multiply the top. This square root of 2 is being multiplied by this whole thing right here. Notice I put it in parentheses for a reason, because you have to distribute. It's going to be the square root of 2 times the square root of 3. Then you're going to take that square root of 2 times this, 3 square root of 2. So let's do the first one. Square root of 2 times square root of 3. Now, the square roots don't cancel out on this, but we can just multiply them together and put them under one big square root. So like, this is what I'm looking at in my head, okay? I'm kind of doing this. Square root of 2 times square root of 3, we have a rule that says if you have 2 separate square roots, we can put it under one big one, like this. So what is that? It's the square root of 6. I'm just doing this for teaching purposes. When you actually do the problem, you should just be able to look at it and say the square root of 2 times square root of 3 is square root of 6. Bam, you're done with that part anyway. Put a plus here because you've got a plus. And then it's the square root of 2 times 3 square root of 2. So you have a number out in front of here. It's just a 1. So 1 times 3 is 3. And then you have the square root of 2 times square root of 2, which is just a 2. So we're going to multiply those together. All right, I hope you see how we did that. Now we're just going to simplify, and we are almost finished. So this is going to give us 6 plus, or I'm sorry, not 6, the square root of 6 plus 3 times 2, which is 6. I can't do those. I can't do anything with those. Okay, they're different terms. The square root of 6 is completely different than a 6. So I can't do anything with those. I just have to leave it. Square root of 6 plus 6. Let's do the bottom. 3 minus. What is this? What's 9 times 2? Well, 9 times 2 is 18. So 3 minus 18 is negative 15. Now, you could keep it like that. I'd be perfectly fine if you kept it like this. But if you do these problems and you look in the back of the book, I believe they take this negative and they put it out front. Okay, so you'll see it like this. And when you have a square root of 6 and a 6 like this, again, it does not matter. This is perfectly fine. I would give you credit for this. But if you look in the book, I think they write it like this. Okay, they just want the whole number first and the square root second. That's all. There's really no big deal on that. And then I just put 15 down there. Notice, instead of having negative in the bottom, you put negative out in the middle. That would be perfectly fine, just like that. And that is how you do example 5, rationalizing the denominator. So that's it. I hope it helps. I gave you the homework assignment in the last video, so I will leave it at that, and we'll see you in class.